Thank you, Jean-Claude. It's a real privilege to be here, so thank you, Min, thank you, Patrick, for creating this opportunity. For us to showcase carbon to value, and in Econic terms, where we're progressing our first target market, which is the polyols market. Some of this is a repetition from previous discussions, but if you look at the world's climate change reduction targets, they're focused on the three biggest areas: energy, transportation, and where we're going to focus today is specifically around industry emissions. So as Minna talked about this morning, 37 billion tons of CO2 are emitted per year. It's a valuable source of carbon. And the challenge going forward is to take what's regarded as a waste today and turn it into a valuable raw material going forward. So Jean-Claude has just talked us through cement and steel, which are the two leading CO2 emitters. And they are emitters based on embedded carbon in addition to emissions. Where we're going to talk about is organic chemistry, and specifically with regard to the chemicals and materials area. So if you look at and you have to be optimistic about the future, bearing in mind the presentations that we've already seen, the moves that are afoot to reduce the carbon footprint from energy means that by 2050, the global emission reduction will be halved. If you look at the moves which are afoot with regard to transportation, and specifically the move to e-mobility and hydrogen power, then effectively transportation emissions reduced by 90% by 2050. If you apply the same logic to the chemicals and materials industry, then there's a 100% increase unless there's some specific intervention to be able to turn that carbon from being regarded as a waste into a valuable raw material. And chemicals and derivatives are the largest sector within that chemicals and materials industrial sector. So the view from the Nova Institute out of Germany and their crystal ball shows that by moving away from fossil-based raw materials to carbon which is available and freely available above the ground today, their optimistic view is that through recycling, through the conversion of CO2 into usable carbon, and through appropriate utilization of bio-based raw materials, then by 2050, it's possible to change supply chains completely. So the move is well underway, which was discussed before lunch, around the recycling technologies, which are well advanced. And it's great to see the progress that's being made there. It doesn't apply to all supply chains, and this is a tough business because there's varied qualities which are required and new supply chains need to be formed. Similarly, for bio-based raw materials, there's seasonal and there's competition with food. So CO2 is the most underdeveloped area in terms of carbon to value. And why is that? When it's abundant, it's cheap, and it's far more consistent quality in comparison to the products which come out of the biofood chain or recycling. And that's primarily because carbon dioxide is such an incredibly stable molecule. It requires energy to transform it. And the challenge for carbon to value is the mass balance or the energy balance required to break the CO2 bond and turn it into usable carbon. And this is where Econic Technologies has a unique position, and we do that through our catalyst technology. And I'll talk some more about that going forward, but there's a combination of supply chains which are going to be needed in order to be able to make the balance, to make this a viable, profitable industry going forward. So as Jean-Claude had talked us through, the cost of CO2 needs to be reduced, but it will always be a cost. And that cost needs to be borne by either the consumer or the taxpayer in terms of subsidies and credits, or by the shareholder of the companies which are producing products going forward. So the carbon capture is an essential, necessary cost that needs to be mitigated. If you look at creation of value through carbon to value, then it's a function of normal production economics. The price of the product which is produced needs to perform equally and have either a cost or an equal or advantage cost position versus the incumbent that is presenting. Sustainability doesn't sell alone if there's any compromise with regard to the cost or the quality of the product. So the price of the end product needs to hold up. The cost of raw materials tends to be in the favor of CO2. It's a cost today, we're turning it into a value. And it's replacing on a one-to-one basis expensive oil-based raw materials. And then there's the processing cost. If you consider there's extra energy that's required in the process or extra costs within the supply chain, they need to be mitigated straight away. So transforming costly waste into value-creating products is really the opportunity here, and it's very difficult to do. So McKinsey's view is that this is tough for most segments of production industry. But we've got to be optimistic, and we've got to be optimistic combining chemical processes to come to a better solution. So if you look at the advancements which again were discussed this morning around hydrogen technology, and you combine that with carbon capture, meaning that CO2 is an abundant raw material and a terrific opportunity, then you can work out the chemical routes to get to today's products, which we all enjoy and enhance our lives with regard to the value that they bring to us all. Specifically for Econic is a catalyst technology, and we have a role to play across a large part of this plastics portfolio. The question is, where do we start, where do we create value, and where do we move the business forward? And this is where our investors are asking us to show that this can be scaled and this can be put into production going forward. And this is where we're very fortunate to be working with Changhua in order to be able to make that happen here in China. Our focus is polyols for the polyurethane industry, and secondly, non-ionic surfactants, specifically for surfactant production. So what differentiates us from our competition? CO2 to value is a great idea, and I'd like to think that Econic had thought about it uniquely, but we're not alone here. Covestro and Aramco have competing technologies. We believe that the market will rise. We believe that our technology is better than theirs, and primarily because of two distinct advantages. Is that if you put CO2 into the backbone of the polymer, you change its properties. But that is an advantage to the producer, is that they can vary their production based on the business that they need to run. So the CO2 can be optimized based on a low-cost solution, or the CO2 can be adjusted based on the higher performance that the CO2 brings to the end molecule. So that ability to tailor the polymer system and incorporate the right amount of CO2 is unique to our technology. Now, the second key unique feature of our technology is the ability to be able to manufacture products in existing polyol facilities. That means that with a relatively modest capex investment, there is the ability to convert existing plants to produce CO2-based polyols, or to build new, as Changhua are. So it's an opportunity to showcase and describe Econic. We're a UK-based company. We're a spin-out from Imperial College London. It's a brilliant chemistry invention by Professor Charlotte Williams, who's on our board, and Mike Kember, who's our CTO. In 2015, they moved the company to Macclesfield near Manchester in the UK, and then very shortly after that built a pilot plant near Liverpool in Runcorn. All of the time the company was run as an R&D organisation, and effectively we've got a portfolio of patents of some 60 granted patents and another 40 in process. And that IP underpins our business model, which is to license our technology and sell our catalysts to polyol producers. There's enough polyol capacity in the world, and the existing supply chain services the market very well. Our ability is to help them service the market even better. We've got 28 employees and a growing organization globally, and we're most proud of our first deals, and specifically with Changhua. And Mr. Kin will follow this discussion to talk about how Changhua are taking our technology and bringing solutions to customers based on CO2-containing polyols and polyurethane systems. So our vision is to redeem CO2 by redefining the makeup of essential products for good. And we're going to do that by getting CO2 into polyol systems. I would be amiss if I didn't talk about our investors. We've got a great group of investors that understand our industry and what we need to do very well, and are extremely supportive of our business, not least of which, of course, is CM Ventures, where we're very proud, bearing in mind the research and the analysis that goes on within CM Ventures to be selected and to be invested in. So specifically our technology, if you take a conventional polymer system manufactured with a conventional catalyst system, then effectively we stay with the same supply chain. But our technology allows producers to incorporate 30% by weight of CO2 into the backbone of the polymers, or up to 30% by weight. For surfactants, we can move to up to 60% by weight. We work through existing formulation supply chains to produce products which are ubiquitous, products that we use every day, products which enhance our lives, which are insulation products for buildings and for our cars and for our fridges, to coatings, adhesives, sealants and elastomers, and surfactants which are used in all areas of water-based formulations. These are growing markets, they're significant markets, they're valuable markets. What we offer is a triple bottom line, and specifically we allow our customers to be able to create value through their process, through a lower production cost, with CO2 replacing propylene oxide or ethylene oxide. It's a cheaper source of raw materials, and we have an efficient manufacturing process that allows folks to be able to manufacture more high-quality products. Our customers and our work is showing that we're providing extra performance with our products. So our products are more durable, they're more harder wearing, they're more chemically and hydrolytically stable than the existing products that are out there. And most importantly, with regard to the discussion here today, we're helping our customers to meet their sustainability goals. By the we've run one LCA on our products, and we're expanding that across PU systems at the moment. But for our existing products versus incumbent technologies, we're showing a 30% improved environmental impact, helping our customers towards their sustainability goals. The key thing for Econic is the time is absolutely right. Consumers for the next generation will make their purchasing decisions based on the sustainability of products, in addition to higher performing and cost competitiveness. And every company around the world, in terms of their ESG report, is moving this forward. So we're working with the supply chain to make this happen. And it's a real pleasure to be here and to hand over to Ryan, who will talk you through what Changhua are doing to make that happen. So thank you very much.